I am A. Anil Kumar, Assistant Professor in Marri Laxman Institute of Technology and Management in Electronics and Communication Engineering. Today I am going to give lecture on embedded system design, and we are having the course outline is course objectives, course outcomes, and course syllabus. We are having the R22 regulation syllabus in our Mlritm. Actually, we are having 5 units in this embedded system design. We are having the 5 units. Unit 1 is introduction to embedded system, and unit 2, coming to unit 2, the typical embedded systems. Actually, unit 3, embedded firmware. Coming to unit 4, RTOS based embedded system design. RTOS means real time operating system. And final last unit 5 is task communication. We are having the course objectives. The students will try to learn, understand the basics of an embedded system. Understand the basics embedded system. What is understand the basics of an embedded system is actually in unit 1, in these course objectives, what are the embedded systems design? What is the embedded system design? What are the applications? What are the major roles by using the embedded system is we are going to discuss in the unit 1 actually. Next one is programming of embedded system. How the programming will be inserted into the embedded system, that will be the second course objective. Like that, designing of an embedded system for different applications. Like first we are said understand the basics of embedded system. Like that only here also, embedded systems different applications where the embedded system will be using. That is the main purpose of this course objective. Understand various operating systems, concepts, and choosing by using RTOS. Understand the various operating systems. We are having the different types of operating systems now, OS. Like that, in this embedded system, how we are going to discuss with the by using operating system in embedded system. That is the main thing in the 4th unit. Like final thing is design, implement, and test of an embedded system. In this, how we are going to design the and implement and test of embedded system, we are discussing in this. Actually, we are having the floor plan as well as design flow, how that will be test, debugging, signalizing, testing. All these things are comes under design, implement, and test of an embedded system. Coming to course outcomes, we are having the COs 5 in, for every subject. Like that only we are having 5 COs to the embedded system design also. In this CO1, understand the process involved in the designing of embedded systems. To the students, what is the designing of embedded system? What is the process involved to design the embedded systems is the first CO. Like that, learn basics of OS and RTOS. We are previously discussed OS, different types of OS are used in the embedded systems. Like learn basics on operating system. OS comes under operating system. Like that, RTOS means real time operating system. How in real time we are using RTOS, so that will be the RTOS, real time operating system, by using embedded system design. Understand types of memory. Already we are known the about memories in the RAM, ROM, permanent, temporary. Like that memories are there. RAM, ROM, flash memory. Like this memories are involved in the embedded systems. How the size will be, how the speed, how will be the cost of the memories. That is all comes under this. Like previous COs, coming to CO4, understand embedded firmware design approaches. How the embedded firmware will be designing is there. That is the thing we are going to discuss in the CO4. And coming to CO5, gain the knowledge of task communication. To gain the knowledge how the task will be there, how will be task will be performing by using this embedded system design. We'll going to discuss in this CO5. We're having the 5 units in this embedded system. First one is Introduction to Embedded Systems. As we discussed with CO's course objectives, in this we're having the definition of embedded systems. Embedded system was general computing systems, history of embedded systems, classification, major application areas, purpose of embedded system, characteristics and quality attributes of embedded system. First, we are going to discuss in first unit. We are having the definition of embedded system. What is embedded system? We are going to discuss first initial stage. What is embedded system? Like next, embedded system versus general computing systems. Some differences will be there as compared to embedded system versus general computing computing system. Sorry. Next, history of embedded system from way to way, from previous year to present generation. Which embedded system will be used? How the performance will be there? How the chip size? How the RAM? How the memory and size? The cost of the embedded system? The design approaches? All of it comes under this history of the embedded systems. And classification. How many classifications are there in embedded system? We are going to discuss in this. Major application areas. We are going to discuss major application areas where the embedded system will be huge. We are going to discuss in these major application areas. We are discussing in this first unit. Purpose of embedded system. Why we are going to use, where we are going to use by using this embedded system. That is the purpose of where we are using. That is the purpose of embedded systems. Characteristics, where how the embedded system will be there. What is the speed? What is the size? That size. That is the comes under characteristics, as well as quality attributes of embedded systems. Quality attributes. In that we are having operational quality attributes, non-operational quality attributes we are having. In that we are going to discuss in this introduction to embedded systems first unit. Coming to the typical embedded systems, that is unit 2. In this unit 2, we are going to discuss about core of the embedded system. Like previously we said general purpose versus embedded systems. In this, we are going to general purpose and domain specific process. We are using in these processors in these embedded systems. ASICs, application specific integrated circuits like PLDs, programmable logic designs, commercial off the shelf components, that is COTS. Memories, as we said, different types of memories, so ROM, RAM, memory architecture, types of interfaces, memory sharding and memory selection for embedded systems, as well as sensors and actuators, as communication interfaces, all this as and onboard and external communication interfaces. How we are internally connecting to each other through embedded systems, we are discussing in this typical embedded systems. Like coming to unit 3, embedded firmware. This we are having different types of circuits we are going to discuss in this embedded firmware, as like reset circuit, brownout protection circuit, oscillator unit, and real-time clock and watch timer. Embedded firmware design approaches and development languages. We are discussing in this embedded firmware. Reset circuit, brownout protection circuit, oscillator. These units are having resistors, capacitors. We are connecting to each other. We are going to discuss all these in this embedded firmware. That is unit 3. Next, coming to unit 4, RTOS based embedded system design. Embedded system design by using the based on real-time operating system, that is RTOS. In this RTOS based embedded systems, operating system basics we are going to discuss, as well as types of operating systems, tasks, process and threads, multiprocessing, multitasking and task scheduling. These all are going to discuss in unit 4 briefly in coming lectures. Next, going to Unit 5, task communication. These are last unit in our embedded system design. Actually, we are having in these topics are shared memory, message passing, remote processor call and sockets, as well as task synchronization, task communication or synchronization issues, task synchronization techniques, and device drivers, and how to choose N autos by using these embedded systems. Device drivers were connecting externally to the device, that is coming under device drivers. Which autos will be using, that will comes under how to choose N autos to the embedded system design. Some different types of textbooks, and we are having references also through our academics textbooks. Embedded system design. In that embedded system, definition of a system. First, we are going to know the definition of a system. A system is an arrangement in which all its units assemble, work together according to a set of rules. What is the definition of embedded system? Definition of a system means a system is an arrangement in which all its units assemble, work together according to a set of rules. How the rules will be given? A set of rules will be given to a unit assemble, work together according to set of rules. Like a system is an arrangement in which all its units assemble, work together according to a set of rules. That is the definition of system. It can also be defined as a way of working, organization, or doing one way or many tasks according to a fixed plan or example. Means we are doing one or many tasks according to a fixed plan. For example, a watch is a time displaying system. Its components follow a set of rules to show time. Watch is the best example to take this example to the system. How means already the existing system will be known. How the watch will be showing the time. Already a set of rule, a set of instruction to given to the watch. In like that manner only, as to the system, a set of rules will be already existing, will be given to system. That is a system is an arrangement in which all its units assemble, work together according to set of rules. That is the thing. For example, a watch is a time displaying system. Its components follow a set of rules to show time. Lot of one of its parts fails, the watch will stop working. If one of its parts will be fails, the watch will be stops working. So we can say in a system all its subcomponents depend on each other. So one to one, that components of a watch depends on one to one to each other. That is the best example to the system. Coming to embedded systems. An embedded system is a specialized computer system designed to perform a specific task within a larger system or device. An embedded system is a specialized computer system designed to perform a specific task only within a larger system or a device. It is a special computer system designed for a larger system or a specific device. These systems are often hidden from the user. These systems are often hidden from our users actually, with their functions predetermined by the larger device or system. They are already integrated into the program or a function predetermined by the larger device or system. They are already integrated into the function or else the code, the whatever may be the function or predetermined by the large device, already inserted to that device, integrated into that device actually. One more definition of embedded system is they are typically composed of a combination of hardware and software tailored for their specific purpose. Actually, the embedded system embedded system design is nothing but the combination of hardware as well as software for a specific purpose means where that discussing that is later. How that will be specifically we are insert to the system or else a device we are going to discuss later. We're coming to major applications areas of embedded systems. Actually, coming to consumer electronics, we're having camcorders, cameras, or generally we are using camcorders, cameras. In that, the already RAM or else the system is inbuilt to the cameras or camcorders. Household appliances. We are using in general daily life, television, DVD players, washing machine, fridge, microwave, etc. I am going to discuss about for a specific task, that is a, for example, a washing machine is there. A washing machine only wash the clothes only. That is the purpose of that washing machine is only the going to wash the clothes only. We are predetermined, already the the source code or else any functions we already given to that washing machine. We are going to, after washing the clothes, please off the switch yourself only. We are predetermined, already programmed for that embedded, programmed to that washing machine. Like fridge is there. Fridge is the purpose of only for cooling purpose. That is not for other purpose like heating or else washing or that is not, that doesn't matter. Only that purpose is for cooling purpose. Micro oven is there. Micro oven is only for heating the object which is inserted into the micro oven. That will be the only purpose. Only we are going to discuss purpose of the embedded system. Washing machine purpose is only for washing the clothes, as well as fridge is only going to cool the items which is inserted into the refrigerator. Like that only microwave only heat the objects or things, food items, whatever may be inserted into the, that will be the purpose of the micro oven. Like that only home automation and security systems, air conditioned ACs, sprinklers, and alarms, so detected alarms, closed circuit televisions, that is CC televisions, camera fire alarms, all are comes under this home automation and security systems, as well as automotive industry. We are already using all our daily life four wheelers. In that four wheelers, we are having anti-lock braking systems. ABS, that is a specialized in the motor vehicles, coming generation vehicles. That is ABS system will be inserted into the automotive industry. That is the in the car itself already inserted. And engine control, ignition system, and automatic navigation system. We are all are using in nowadays Google Maps navigation. That is we are going to use by this embedded system only in the where we are telecom, like computer peripherals. In computer peripherals, we are going to use printers, scanners, fax machines, etc. And coming to computer network systems, network routers as well as switches, hops, firewalls, etc. All these all are comes under major applications area of embedded systems. This is all about today's lecture. Thank you.